All right, I think this works. So, thank you very much, Casper. I'm here to talk about mainly Kubernetes operators, and I'm going to put it in a maybe not so fancy title, talking about compliance in this. Yeah, the title is Compliant Postgres Access Management with Kubernetes Operators. So just a short word about me. My name is Bjørn, and I work as a web architect at Lunar, and I've been there since 2017. That's my Twitter handle. Feel free to reach out with any questions. So today we're going to talk about who we are, just short about Lunar and the journey we're on, and then we're going to talk about the what and the why in compliance. Why is this even interesting to talk about? Maybe it isn't. I'm going to summarize that into the challenge we're facing, and then we're going to talk about the implementation. And spoiler alert, the implementation involves Kubernetes operators. So, who is Lunar? It's a bit dark, but we are a 21st century bank. That means we're trying to build a bank in a new way. We're gonna try to make a only digital bank, and no branches, no clerk behind a desk in every small town handing over money. It's all digital. You got a mobile app, you got a chat system with the supporters, and that's all you need. And that should fit all your needs. And of course, we're going to do this a bit more fun than mainframes. We're building on Cloud Native software and the philosophy regarding this. We're going to try to move fast, hopefully faster than all the traditional banks, but let's see how that goes. So far, it's been pretty great. And we're on a journey. I'll come back to that. So some boring facts, according to Henrik, about the company. We're plus 100 employees, 150,000 users. A bit technical, we got around 100 microservices running on 3 clusters. And 25% of the employees is engineers. So we're getting bigger and bigger regarding to the team size, and that imposes some complications. So, what and why compliance? Let's see why this is. Well, how can compliance be interesting, really? It might not be interesting, but it is a requirement because we got a license to build a bank. That is back in August 2019. We got a license from Danish FSA, Financial Supervisory Authority, so we can do banking business. With this comes a lot of regulation, and I say a lot of regulation. We need to be compliant in all sorts of ways. So what we're trying to do in the journey we're on is building a bank from scratch that is no legacy systems except our own, no mainframes, let's see, no branches, as I said. We're gonna not put up some data center with laser security and a bank vault with 10 inches thick iron walls, and so it's 100% digital. We got no cash, we got no physical money. Everything is on the internet. Yeah, so it turns out that this is hard. Doing compliant things is not logging into a database and just fixing this record, this user's email was something else, and we're just going to fix that. No, that's not how it works. So we need to be very, very careful not to do something wrong regarding regulations, and we need to have good answers when questions come. So when the regulation, the Danish FSA comes and say, why did this developer have access to this user's data? Or they ask, why does any developers have access to user data? We should be able to answer clearly and to tell the process of how they got this data, how they got available and what they did to it. And not the least, why they needed access to the data. So there's a lot of things about audit, there's a lot of things about release processes, review, availability. If a bank goes down for a day, that is not well looked upon. You should be able to use your credit card, and there's rules for these things. So we need to look into this. So to put it in a bit more words, compliance is about trust. We need to gain the trust of our customers. We need to gain trust about the FSA, that we're doing things right. The customers is important because it's their money. If you don't trust us, you don't put your money in the app or on your account. So compliance is here to ensure we do a good job about this. History has shown that other banks might not deal with users' money in such a good way. So we should be careful to handle these things great. There's another aspect of this. We need to trust our developers, and developers need to trust the company. If I'm scared of being accused of modifying a user's data or stealing money or something like that in the data systems, I should be confident that there's a clear audit trail indicating that I did not do such a thing. So it's just as much about finding out who did things as much as it is about who didn't do things. Yeah. So we could, of course, make this easy. Say, talk about access to user data. We could just say, all right, let's see, every time a user needs to access data, they need to fill out this form. And just say, why do you need this? What data is it? What time is it? And a signature, and put it up to the manager. And the manager will put a stamp on it, and that's it. Yeah, that could work, I guess. And some companies actually do this, but that doesn't really scale. Furthermore, it doesn't really drive the developer experience that we'd like. So if a developer gets assigned a support ticket, they should be able to fix this right away. They shouldn't wait for a manager to put a stamp on some paper or fill out a paper form at least. So we need to make things smarter. And that brings me to the next point. Compliance is always about also about technology. We need to make sure that the processes that we take into account is based on technology, because that has proven to scale really well and makes developers happy. They can keep on moving, and we got strong audits that doesn't have to be looked at by some person that looks, oh well, Bjørn had access to this data at, let's see, yeah, that date, so that's good. Or did we miss a paper somewhere? So technology is important for us. As I said, we're building a bank from scratch, so we have no legacy systems except our own. And as a startup, you always have legacy systems. But we don't have any mainframes. We don't have software that's been in production for 20 years. That is hard to understand. That was built by someone who could have been your father. Everything is built within the last 5 years, I guess. Yeah. So not so much legacy, I hope. So we use technology to move these things forward, and we question all the authorities saying you need audit, you need availability, and say why, and make sure that we only do the least important things, or the least make it done as fast as we can with the least effort that we think is okay, and the regulatory authorities think is okay. So, looking back, I talked a bit about it already. The company is just coming up on its 5 years anniversary, or birthday, if you will. So it's been quite simple to get access to databases. We had one database. We had a couple of engineers. And did you need access? Yeah, well, you got it already. You knew the password. It was on the paper on that disk or something like that. No, that's not true. Hopefully. Onboarding new engineers and offboarding was rare. And creating new databases is a manual thing. So let's say, as I said, we were using microservices. We got 100. That was not the case back then. But when you need a new database, you would connect to a database using PSQL or some other tool. Call the SQL command for creating a new database and remembering to store the password somewhere safe and all that, yada yada. Error-prone workflows. Furthermore, you had to exec into our VPCs because the database is hosted in AWS. So you need to get into the virtual private networks first. Furthermore, so you have some point in your system where every developer can SSH in and then do all kinds of interesting things. So we don't want that. We don't want that at all. So now we got, as I said, around 25, I think 28 engineers as of today. And we're hiring still. Feel free to join. We got over 100 databases now, and we need to do this more clever than creating them ourselves by hand in shell scripts. So the challenge, I've come up with 4 points, 4 bullets that I'd like to dive into here. Number 1, we need to keep developers productive. We are a small shop, fairly small shop for being a bank. We need to move fast. We need to deliver features for our users and our investors. And we need to keep our developers happy, otherwise they'll find another job. Number 2, we need to keep user data safe. As I mentioned before, we need to gain the trust of our users. So it is paramount that we keep data safe. We need to be compliant. It's a bit boring, but that's how it is to be a bank. We need to we need to ensure that the FSA is happy all the time. And not least, we need, or at least we don't want any manual work. So we could keep the developers productive by dedicating someone to sit and do these forms. And that was that person's only job. But that creates manual work, and we can use those resources better. So diving into each one of these in another order than I just said them. That's going to be fun. We need to stay safe. We need to ensure that the data we keep on our users is safe. It's stored securely. It is their money. And we need to make sure that we can tell if money goes lost or some data is inconsistent. We need to understand why this was the case. We cannot be sure that this never happens, because then we couldn't do anything. We work and release new software every day, so mistakes are going to happen. But we need a way to ensure that we can explain why did this go sideways. Why did this person lose 100 kroners or something like that. So traceability of these things is paramount. And then, as I said earlier, we need to keep developers safe as well. So no false accusations about what did you do with your access, and why did this happen. So clear audit trails for these things is an easy way to ensure most of these points. Then we're gonna see the compliant part. I've talked about it already, but the FSA requires us to have clear processes for most of the things we do. So how do you release some software? How do you access user data? Yada, yada. We need to have processes, documents explaining why and how. And we need to have audit logs of what is going on. Who did actually use these processes? We've been over that. The manual tasks. We cannot have anybody sitting at a desk granting access to anything. We don't want access managers and yeah, we need to move faster than that. And we need to use the resources we have, the employees we have, to do a better job than just sitting doing robot stamps on something. So we need to ensure that there are absolutely no manual tasks involved in creating a new database. Say, of course, you need a manual thing like, I need a database in the first place. That is something that the developer puts out. But from there on to the database is ready for them to use, there should be no manual task involved. And last but not least, stay productive and keep moving forward. We need to keep working, we need to deliver features, and we need to not pay that much attention of getting something as trivial as a database up and running. That should be the least of our problems. And one important point here is that developers are lazy. We all are. If there's an easier way to do something that circumvents the processes, we need to do that. We need to fix that. We need to make everything we do easier than the wrong ways to do it. So, to this point, I'm just going to remark that we are using the Google Suite, the G Suite, to authenticate to our Kubernetes clusters already. And one of the ways that we could keep access to databases easy for our developers is to reuse the same ways of logging into a cluster, is logging into a database, or logging into the Gmail app. We need to, if we can align on the same mechanisms, it's known to developers. They only need to know one thing, and they can use the same passwords and the same flows for everything. We'll get back to that part. So that leaves us with a couple of functional requirements, and probably a lot more. And yeah, these are the ones that I thought about when doing this talk. So these were the main points that we needed to fix when we started looking into this. We need a way to create databases. We need to create roles for these applications. As I said, we're using Postgres. How many is unfamiliar with Postgres? To some. All right, that's it's probably the same as most other database systems, but we got a role system that grants you access to different things, and roles can inherit other roles and all sorts of crazy things. So we need a way to create a role that application services can use to actually access the database in the first place. So that's the application side of it. Then we also need some roles to access the database from the developer's perspective. So say I want access to the user database, there should be some roles in there that grants me that right. Then we need some granular access requirements. So we need to do this on each and every one of the databases. So it's not you got access to everything or nothing. You should be able to get access to a single database or a single schema in that database and something like that. And last but not least, we need to use AWS's IAM authentication mechanisms. That's regarding the G Suite implementation. AWS, it's a hosted Postgres instance, or it's hosted Postgres instances we use, and that means it's fairly integrated with IAM, that is AWS's authentication solution. So if we can make it work with IAM, it should be able to work with the G Suite as well. So we'll get back to that as well. But those were the functional requirements. If we could solve this, we would take off all the manual tasks that developers are using. We would take out some of the insecure processes that we have today. No reused passwords, no passwords on sticker notes and something like that. We could make it easier for developers to get a new database. And in this process, we also make the FSA happy, because it's clear how does a database get created, how does somebody get granted access to this. So, moving on to the fun part, the implementation. So, as we are a cloud native shop, we already got a Kubernetes system running. That is, we got Kubernetes clusters. We are used to thinking about resource. You got a question?
Yeah, I just want to ask, when you say database, what do you actually mean? Because you also mentioned an instance. So you're talking about creating database on the one single instance you have, or are you also creating instances?
Yeah, all right. The question was what I mean by databases and instances. Yeah, sure. We are talking about databases on instances, and we are automating the creation of databases on instances. We do not automate instances in itself. So these are managed by AWS in RDS, and we can create them with Terraform or whatever tool we like, but we do not take responsibility of creating the instances in the first place. That is outside the scope of this, and managed by the platform team at Lunar. That is me and Casper. And Emil. Yeah. So, yeah. Did that clear it?
Yeah.
Yeah, great. So, good question. Thanks. As I said, we're a cloud native shop and we have Kubernetes running, so the obvious choice for us was to use operators. That is Kubernetes operators. And just taken out of the Kubernetes documentation, I'll just cite this. Operators are software extensions to Kubernetes that make use of custom resources to manage applications and their components. How many of you are unfamiliar with the operator pattern or custom resources and stuff like that? All right, quite a few. I'll try to keep it introductory. So please raise your hand if something is unclear, so we can fix that. Yeah. So operators. Just to find out how popular this is, I searched for topics including the operator name. And there was 381 public repositories available at the time I took the screenshot. There is some confusion around operators versus controllers. The Kubernetes own components are called controllers for most things. So just to highlight these, controllers to the left, they reconcile state. Let's say a deployment got the controller manager that's forgot the name. I'll come back to that. All right, it reconciles states, so you got a desired state and you got the actual state, and try to reconcile these things and make sure that their desired state is actually what we get. Furthermore, it interacts with the Kubernetes API to find out what is the desired state. That's what's stored in etcd. Operators, on the other hand, is the same, but it adds 2 points. And to be honest, there is a lot of confusion about what is what here. Operators versus controllers, and people use these interchangeably. So to me, at least, operators is extending the Kubernetes API instead of just using the existing resources. And it's probably contains a bit more domain logic. Let's say a MySQL operator that spins up instances of MySQL in the cluster. Well, it knows something about how do you do rollouts of new versions and manage these states and so forth. So it's a bit more about the domain than just, is there two? No, there isn't, so add another one or something like that. But yeah, people use them interchangeably, and yeah, as we're gonna see, we used the wrong word for our controller, operator, according to these slides, so bear with me. And if anybody got some clear definitions, please come up afterwards and enlighten me. Yeah, so just to recap, reconciliation is what's, I think, one of the primary features of Kubernetes. That is, we got a desired state, we got some deployment that says we need 3 replicas of Nginx running, and then got the current state. There is no Nginx pods running. The deployment specifies the number and the template of the pods. And then the controller manager will try to say, all right, there is none, and I need 3, so I'll spin up 3 new pods. So that's basically just, it's a way of fixing undesired state and making it match the desired state. So in this case, that's a controller, according to my own definition of the controller. It uses pods, it uses deployments, it's native Kubernetes objects. What we did was to create an operator that's called a Postgres control. Yeah. I thought about renaming this, but the GitHub repo is a controller, so that would just be odd. All right. Anyways, what we did here was we needed some resource, and as Kubernetes don't have any native database resources or database user resources, we need to have some custom resource definitions. So that's the document on the left. Then we got the controller. The document specifies the desired state. I need access to this database, and the controller will then make sure that that access is actually granted on the RDS databases, the database instances hosted by AWS. So this makes it possible to get access to things, but as I just spent around 10 minutes talking about compliance, this doesn't sound that compliant, because everybody can just add a new resource to etcd, and this controller will add them to the database. So, hey, I'll need access to all the users' tokens. Yeah, that sounds good. No, so we need something more than this, but it's a foundation. So, that's a little blob on the right, and then all the compliance parts, almost. We are using GitOps for deployment at Lunar. That is, every resource that the Kubernetes clusters hold are committed into a Git repository. That's the thing in the middle, the config repository. So as you can see, there's a component inside the cluster called Flux that will reconcile, again, what is in the Git repository and what is currently in etcd. So that's the part where that is how we get resource into the cluster in the first place. Then we need some way to put things into the config repository, and that is done through Jenkins in our CI pipelines. That is moving on to a specific access repository. So just to sum it up, a developer at the far left needs access to a user database. So he will write a custom resource that says, I want a Postgres user, my name is this, and I want access to this database with this reason. That'll be put in a pull request. Some peer in the organization will say, that sounds like a good reason. You got a support ticket, that's all good. He'll approve this, it'll get merged, and also released into the environments that's applicable through CI. Also released in these terms is the resource is committed into the config repository for the given environment. So it says it's a production environment, and we just commit this resource into the config repository for the production environment, and Flux will reconcile this, put it into etcd. The Postgres controller will reconcile what's in etcd and will set up the roles in the database. That's simple, right? Question?
How is that different from someone handing a form to some guy who then approves it?
Technology is the difference.
Okay.
The main thing about the question was how it was different from a guy stamping a document is there's no manual tasks involved here. There's someone approving the PR. That is the manual task. And that's the audit part. We need someone to say, you got a good reason for this.
But isn't that the same as putting the stamp down?
Yeah, it is. But this could be anybody. This is not a guy whose only job is to approve pull requests. Oh, that would be horrible. No, it's anybody. So a team member or a manager or somebody, say I'm working late at night and somebody else is working remotely late at night, great, that guy will do it. Or so there's no one person doing this, and that's why it's a peer and not a manager of some sort. So that's how we go about it. But yeah, sure, we still need review. We need to understand that you got a good reason for these, after all. So that actually brings me to the red parts, the red text. And you are not really able to read that, aren't you? Anyways, we got 4 places where audit kicks in here, again, to keep the FSA happy. The first one is the PR. So you got a peer reviewing your request that is committed into this repository. So you got a git log with signed commits that says this guy needs access to this database and somebody reviewed this. That is signed and committed. So we got a git log here saying all changes to access requests are stored here. Then again, in the config repository, these are more Kubernetes close resources. Say we could use some templating on the left side in the access repository, but when it comes to the config repository, that is the raw YAML configuration. So there's another audit log. It's noisy because there's all the other deployments, but it's there, and you can see when did some change go out to the given environment. There's a time gap here from somebody approves the PR to that is merged. The CI has built it, validated the resources, and pushed it into the config repository. So that is why the two audit tracks are interesting to keep. Then we go into the cluster. The Postgres controller in itself keeps an audit track. So it will log every change it does to every resource, why it did it, and what resource it was, and what it did to it. So it's revoking some access, or it's granting some access to a database. So that is just the log of all the changes that comes through. And then last but not least, and really the most important audit track, is the one from the database itself. So we got audit logging enabled in the Postgres instances. That is, every query done on these roles are stored in logs and pushed into a Humio instance. So we track all the changes, all the queries you execute is stored for later review. So that means when the FSA comes and say, why did this user have access to this data? We can look into the config access repository and say, all right, the reason was this support ticket. You can say, why was my money gone? Somebody updated the balance negatively. All right, we can look at the query logs and see, well, this user did this. And why did this user have access? We can follow back to the original request and say, well, it was based on a support ticket that said the balance was wrong. And we got everything nice and easy, at least to the FSA requirements. That's another question.
So aren't you missing an audit of Jenkins? And I just hardcode my user into the Jenkins pipeline, and then I always have access.
Hardcode the user.
Like you're saying that the Jenkins pipeline is triggered by the PR request.
Yes.
Who audits the changes made to that Jenkins pipeline?
There,
CI.
there is no changes to the pipeline itself.
It's not something you have built up and, some scripts or some third-party things?
No, to be honest, the access repository is the raw YAML, and then there's a couple of verification steps. That's the CI part.
Okay.
Yeah, so it'll just do some static analysis, saying there has to be a reason here, otherwise there's no need to push it into the cluster and all that. Just makes static analysis, making sure everything looks good, and it'll commit it to the config repository. That's it. There's nothing in between here. There could be some templating, something going on, and then, of course, that needs to be audited as well. But every code change in Lunar is already required to be audited, so reviewed by someone else. So at least there's two peers to every change on everything. Oh, more questions. Time is running out. Yeah?
I heard it as, can I make a pull request to the pipeline repo, the repo with the pipeline code?
Yes, you can. You can make a pull request, and somebody has to
circumvent the...
Yeah, but then you gotta be two guys or two girls or a guy and a girl. I don't know. But you need to be more than one developer. You need to keep these things in. And for the more critical parts, often it's somebody who owns it. Or so let's say we own the platform team and got some critical integrations that, let's say this pipeline script. It has to be audited between us in the platform team, and if somebody else makes a PR, it also has to be audited by us. So there's some limits to what you can do. But of course, nothing is bulletproof, I guess. All right, let's move on. That was the audit trail. Let's see if I can keep track of this. Another diagram. I talked about G Suite earlier. And for those who knows Postgres roles, if I add a role in the Postgres instance or the database, that doesn't really make the developer able to log into anything. There needs to be something else here. So what we do is we facilitate AWS's IAM service. So a developer contacts G Suite and does a single sign-on to AWS. That gives them an STS token. That means they can get specific tokens in AWS to do stuff on AWS, if that makes sense. specifically, it grants them the rights to generate these DB auth tokens. That is some time-limited tokens that can be used to passwords when connecting to the database. That means you authenticate to G Suite, you get a lease to be able to request these tokens. You can then use that token to, say, use PSQL or some other database UI you want, and connect directly to the RDS instances. So that is what AWS provides. They can authorize who can connect to the database, not what can you see on the database, what databases on the instance. Oh, sorry, let me be clear. You can connect to the instances, but it doesn't tell you anything about what resources on the instances can you interact with. Can you update a record, or can you delete a query, or truncate, or drop a table, or something like that. That's where our component comes in. That gives you the additional grants that makes it possible to, say, query and select some rows from the user database or something. So that's the part. So in practice, all this is just another role in the Postgres database. It's called RDS IAM. So when you authenticate through this, you get granted this role, and that makes it possible for us to grant you additional roles, and you can sign into the database. It's a bit convoluted, but I thought I'd bring it here, at least for reference. Yeah, we're in the section of implementing, and we still haven't implemented anything, but we have thought about things. So let's begin to talk about operators, shall we? Time is running out. Yeah, operators. There's plenty of options of creating operators, frameworks and such. I've brought the three operator patterns, SDKs or frameworks that we considered when we looked into this, but there's come plenty since. Look it up. There's all kinds of fun ways to create operators, from simple webhooks to the operator SDK that we use, that is very centric around building the application yourself. So the operator SDK is built by Core OS, and that is the company that also coined the operator term initially. They provide this SDK that brings you some high-level abstractions. You don't have to interact that much with the client Go library. It provides some scaffolding, code generation. Say you got a resource, it'll provide you all the schema validation for Kubernetes and such. For day 2 operations, they provide the operator lifecycle manager. That is a component that is great when you got, say, an operator running MySQL instances, and you got 100 MySQL instances running in your cluster, and you need to upgrade the versions. So that's around how do you update versions of the operator itself and so forth. That is great. And just a great resource for learning more. They got an awesome operators repository and the official operator framework GitHub organization, and it got currently 138 operators listed there. So all things from MySQL to etcd cluster operators and yeah, all kinds of fun things. So take a look there if you need inspiration of what you can do with an operator, and maybe also something you shouldn't do with an operator, I guess. The other option is KubeBuilder. It's much like the operator SDK. It's built by the special interest group of Kubernetes called the API Machinery. They are the ones maintaining the underlying lib that the operator SDK is also using, the controller runtime. So it's pretty much the same logic and the same APIs you can interact with, but they put a bit another of an abstraction to the code generation and such on top of it. They also support admission and custom resource conversion webhooks that the operator SDK does not support that. So if you want to create admission webhooks and such, this is a great thing to use. And last but not least, the sample controller. It's a copy to your destination and rename things. It is literally a sample of how does Kubernetes think controllers should look like, and it's what their own controllers are based off. So there's no tooling here. There's no auto upgrades, no code generation, no things like that. It's just copy this project, rename it, and start from there. It's reference implementation. But still great, and maintained by the same SIG API machinery. Yeah. So custom resource. Let's look at YAML. Yeah. Now it gets interesting, right? Yeah. That's 40 minutes in before the first YAML. That's impressive. All right. So as I said, we got a concern around databases, and we got a concern about users. This is the custom resource, an example of a resource of the database thing. Kind PostgreSQL database. That's an awesome name to put in Control get post. Yeah. So what you see here is you got the usual metadata fields, and then you got a spec, much like you know it from all the other resources. So here I spec, I want a Cloud Native Nordics database. Its host value, so the instance that this database should be created on is postgrescloudnativenordics.com. And the password is pulled out of a secret called Cloud Native Nordics in the DB password. If you are familiar with deployments, you'll know you'll recognize the way of referencing values from other resources, say config maps and secrets and so forth. And that can be used in most of these. So this is what we try to say. From a developer perspective, I'm writing a new service. I need a database. This is all I care about: the password and the name, and the host it should be put on. That's all I need. If I put this in within my service deployment, I can be sure there's a database available to me. That's the first thing. Then there's the user. And this is me, my initials at Lunar are BSO. What I'm asking here is I want some read permissions. That's an array, so I can have multiple of these. I use the special all databases true flag. It sounds hacky, and it is not. It's intentional, but what it says is for all the Postgres databases that you know, I want read access. It's great for development environments where you don't need specific rights. There's no confidential data. Everybody can read everything. There's also a specific database field, and we'll get back to that, that can use the granularity that we need in production systems. So here I'm saying I want access to all the databases you know on the same host as the database we just saw, and I got a great reason for that. So when you're using the operator SDK, you're using Go, and you're writing structs to represent these custom resources. Can you read this? Great. Some question? Yeah.
I have a question about the previous slide.
Yeah.
Why not go for something like RBAC definitions and reference your CRD and say CRD like Postgres database X read write whatever, you know?
Yeah, we could do that, but this to us was simpler for our developers to look into.
Okay.
Just be honest. Yeah, it was simple enough, but covered our needs. Maybe down the line we'll regret that and use a more sophisticated setup, and then we'll migrate and have a headache. That's how it is. Yeah, if that's an answer. Yeah. Yes. So, as I said, we're defining Gostructs. So here we got the user spec, we got the name, and we got a read and a write slice, that's array in YAML. And as you can see, we got the host field that was required. I don't know if you actually can see anything up here. There's a host here. Then we got the all databases Boolean. Got a database resource var that is a reference to, say, a hard-coded value or a config map or a secret with these keys in. Same goes with the schema. You got a reason that's required as well. And then you got a start and stop time. And that's a little twist on this. If you ask write access to a database for a support ticket, we don't want you to remember to revoke this access when you're done with the ticket. So instead, you put in a stop, say, well, for the rest of the day, I need write access to fix this issue, and then it'll automatically be revoked after that time. And you can do the same for the start and say, on Monday, I need access to this, but I'm just preparing to take up this task or something like that. So you define these structs, you run an operator SDK command, it'll generate one hell of a lot of YAML, and some validations, schema validations. As you can see, there's some annotations like /s plus optional, and that'll be translated into OpenAPI validations. So when you try to run kubectl create PostgreSQL user, it'll do some initial validation right up front. There's all sorts of keywords you can use here. And this is the whole reconcile function with a couple of details omitted. I should have picked another background. The essence is really when you use the operator SK, you implement a reconcile function, a method. You'll get a request object that is enough for you to uniquely identify the resource in the Kubernetes APIs. You'll fetch this API first thing, and you'll decide what to do from here. The most important things from here is that everything you do has to be idempotent. That is, if you see this twice, you should have the exactly same outcome. If you get interrupted in the middle and you see the resource again, you should be able to reconcile that bug or fix the intermediate states that you have created. So say I got the service, I got the database created, but I didn't get to creating the role before this pod was terminated. Next time I start up, I get the same request in, and I should just keep on working. So say, oh, I need to create the database. Oh, it's already there. Great, moving on. So it has to be idempotent. You're going to see requests multiple times for the same resource, and you never know what changed. That's important. So just do everything you need to do every time you see the resource, and it'll work great. I've omitted some details about this. Only ensures the Postgres roles. That is, I'm setting up the roles that need to be set up, but I don't do anything about IAM. We also do a hook into AWS regarding the IAM roles, making sure that I can actually connect to these systems. The source code is available. It's open source in a Lunar organization at GitHub, and I'll link to it at the end, so you can look into more details if you're interested. And now it's time for a demo, and my time is out. It's fine. I'm gonna try to do this quickly. And whenever you try to do a demo quickly, it's gonna not work. So first I need to show you the screen, and I'm just gonna see if, oh, no, that's not what I want. See if I can mirror these screens. There we are, mirror. So you can see the terminal? Yes. And I can see the terminal, that's great. That's not the word. All right, so I'm just going to show you, just briefly, the operator in action in a local cluster, a kind cluster. I just started it before the talk started, so I'm going to watch for resources. I'm going to watch for pods, PostgreSQL databases, and PostgreSQL users. And as I start this, I'm getting an error that says, I don't know the resource type PostgreSQL. I haven't started it. It's a completely empty cluster. The custom resource definition is not in the cluster yet, so I can't see anything about this. So, yeah, and is the font big enough? It's okay. Great. And we're going to move on to this screen, and I'm going to follow my guides here, and I'm going to call make resources. What this does is it's going to create RBAC service accounts. It's actually ready for the Postgres controller to be deployed inside the cluster. We're not going to do this in the demo. I'm just going to run it locally, connected to the cluster. Then it's creating the custom resource definitions for both the database and for the users. And if everything is well, we should. And it's creating a PostgreSQL instance running in a pod here. So now the watch is working. I don't get an error. It knows the resources. There's none of them, but it knows them. And we can see the pod is starting up. It's a PostgreSQL 11 instance. I'm just going to wait and see if it starts. And then we're going to try to create a resource in it. Waiting. Yeah, great. 60 seconds. All right. I should have a joke. Yeah, loading bar. Really. I'm 10% done with creating this Postgres instance.
I have a question.
Yes, please.
What was the challenge of making it you said if this time the job created the database but didn't create a row, the next time the job should be able to execute the same and they should create the same result. But that comes out of the box with Postgres.
Yeah, but the difference is if I try to create a database, say I'm running create database in Postgres, the client libraries will give me an error. And the important part here is to differentiate this error from the database that already exists and I can't connect to the instance, something like that. So it's not, I don't have to know, Postgres gives me a lot of these, and actually what we do is we try to create the roles, we try to create the database, we identify the errors that we get returned and say, is this something that's okay, it's expected, say the database already exists. If that's the case, then it's great, return no errors, because that's expected behavior. If you just say, run this query and return the errors, then you're gonna stop the loop every time. So it's not that you have to take it into account, especially the important part is that you shouldn't insert things or you just shouldn't drop things. You should always update or insert things.
But what do you insert when you just create a role?
Yeah, in this case, it's not important, but it's a more general observation of writing operators. You need to be aware of everything you do here has to be, let's say you're writing a DNS operator and you create DNS records in AWS based on some resources. If you see the same resource multiple times, you don't want to put in multiple resources in DNS records.
So it should be functional.
Function.
Like functional programming.
Yeah, it could be. Yeah, well, it's just the nature of being idempotent. However you put it is, I guess, fine. And it's very domain specific when something is okay to continue with and when something's not. I hope it answers the question. I can show the code afterwards if you want to know the specifics of this idempotency handling. Yeah. All right. The Postgres instance started. And I'm just going to move to a small font screen and forward the Postgres instance to my local machine. It's just a kube control port forward, and it's not important. Or it is. But so here we're gonna, I think we're gonna try to create the database. I got a YAML here, much like the one I showed earlier. It says I want a Cloud Native database. It's on the host PostgreSQL. And it's got the amazing password. The password here is for the applications to use and not for the developers. So I'm just going to apply this, kubectl apply f demo database. And if we go back to the watch, we'll see, hey, the resource is created. So far, the controller is not running. So as you can see, there is no status here. There's nothing updated. There's no host information. This is just the resource is put into etcd. No one has done anything about it. It's just it exists. That's a bit boring. So let's try to see if we can start the controller. And that is a great command here. Yeah. So basically, I'm compiling the source. I'm running the main function. I got a couple of flags indicating what credentials should be used. To create new roles, you need some user on the database to create new roles. So here I'm using the IAM creator role. That's the admin password of this pod that I started. In production environments, these should be specific roles created just for this. So I'm just going to try and start the controller. And hopefully we're going to see some logs. And we saw a lot of logs. The intention here is, as the controller starts, get all the resources in etcd. And so it should have gotten the database resource we just created. And if we move back to the watcher, we can see that now there is a running status, and it's been updated. So, in other words, the controller has seen the resource, it has created the database in this complete empty instance, and that is great. So let's see if we can get access to it. Let's see, we got a demo user YAML here. Again, much like the one we saw just before, I want to create a BSO user. it's on the same host as we just saw, and want read access to all the databases in this. Currently, there's only one, so that'll be that. I'm also specifying that I want write access to a specific database. It's the same, so that's great. Let's apply this. kubectl apply fdemo user. So back to the watcher, we can see the resource is in etcd, and if we jump to the logs, we should see a blob here. This is the important part. We see it. The first thing the reconciliation loop does is print out, I'm starting to reconcile this resource. Then it's connecting to the database. That went well. It's creating the role. It's granting me read access to the database, and it's granting me read-write access to the database. We made a concern about whether it would make sense to only allow writes, but you probably most often want to see the data before you write to the data, so it's a read-write role when you ask for writes. So with this in place, I should be able to sign into this database. And just for the sake of it, we don't got IAM in this setup. It's just I got the role set up. So if I run PSQL, I want to connect to the local host, the Cloud Native database. That's the one we just created, and I'm connecting to BSO. That's the database user. And we watch what are the users in this database. We can see that my user is there, BSO. It's lucky as I just signed in with it. We got the Cloud Native user. That's the one used by the services, say the application that's in need of this database. And then we got two roles for the read and for the read-write that is created with the database. And those are the roles that are granted to my role when I ask for permissions to get these things. As you can see over here, I'm a member of these two roles. Yeah. So if I remove the read, now we are running out of time, so maybe I shouldn't show it. But if I remove the write section from the YAML and apply that to Kubernetes, I should see that this read-write role would be taken away. But you get the sense, I hope. So that was it for the demo. And just last, I want to say thank you for your patience and sorry for going over time. And hopefully there's some questions. And here's some links to the other Lunar blogs, talks, some open source. And the last one is the link directly to the source code of this controller. Bear in mind, it's under active development, and some of the features I've shown or talked about today are not actually implemented. So it'll be in the next couple of days or weeks or months, who knows. But yeah, that was it. Question?
I have a quick question. If
Yes.
someone deletes some of the things you made in passwords behind the back, will
Yes.
it then reconcile?
Yes. Yes. That's an important part of it. And there's some controllers, some operators does not do this, and some does. But the important part is, what do you want to watch the resources that you created on something after you created it initially? That is reconcile side effects from other systems. So if I go in and remove the role, I will not get notified. But instead, what we do is we got a daemon running in the controller that'll, in a fixed interval, will look for changes and reconcile and make sure everything is still in sync. So that works for this application. Yeah.
Awesome. Let's give him a big round of applause.